So again, this is 3-1 and 3-2. Okay, I just gave you the 3-3 and 3-4. That's the 1-4 tonight. But the 3-1, 3-2, fairly simple. It's just balancing equations and then some simple predicting reactions. We're not going nearly into as much detail about this as we did last year because they changed the exam. You don't have to worry about writing equations quite so much, which is nice. So this right here, this little blurb on balancing equations, they don't talk a lot about it in the book, but here's just kind of a reminder to you of how this works. So you guys remember how I taught you to do it last year? So let's say you're balancing a simple equation like CH4 plus O2 yields CO2 plus H2O, okay? All you need to do here is just make a list of the elements underneath: carbon, hydrogen, oxygen. Yeah, that's not going to work. There we go. So why did I put the oxygen last? Okay, yeah, I mean, it's changing, but look at where it is in the equation. Multiple places, right? See that in this part of the equation? It's in 2 places. So you always want to save that one for last because those are the ones that are going to be a pain. Okay? So then you just you count up how many are on each side. We've got 1 carbon on the left, 1 carbon on the right. Whoops, I was looking at oxygen. 4 hydrogens on the left. And how many on the right? 2. And then we've got 2 oxygens on the left and 3 oxygens on the right. Okay? So first thing I'd want to do is balance the hydrogens. The carbons are already fine, right? So then I just put a 2 in front of the H2O. That's going to give me 4. So you just cross out your numbers and change that. Now this down here, this is just a way to tally up how many of each you have, just to keep track. The actual balancing happens based on where you put the coefficients, okay? And if you get to a point where you don't need to do this anymore, that's fine. This bottom part, that's just the tally, okay? So now, that also changed my oxygens though, so now I have 4 oxygens on this side, which is kind of nice. Because now all I have to do is just put a 2 right here, okay? Now, it might not have been that easy if I had done oxygen before I did hydrogen, but a lot of times if you do this in the right order, the balancing kind of just takes care of itself, okay? You guys remember that whole process? I mean, it's pretty simple, so I don't think we need to belabor that point too much. So this is just some practice with balancing. The AP Chemistry new course description. I don't know that there's anything real special here that we need to talk about. Now, here's where we do need to talk. Symbolic representation versus a particulate drawing, okay? A symbolic representation is what we just did, okay? Representing with chemical symbols, so CH4, okay? Now, what would a particulate drawing, so this is the symbolic representation, right, CH4. What would a particulate drawing look like for CH4? It would be like some sort of, ball and stick model or space filling model or something like that. So, it might look like this. You've got your carbon here in the middle, okay? Now, I'm going to butcher this a little bit, but this is essentially, this is to show that it's coming out from the screen. I don't know if you guys remember me showing that to you last year or not. But maybe we've got a hydrogen here, okay? And then, remember, this kind of ends up being sort of like a tripod type thing. Hydrogen here, and then we've got one kind of going back into the screen here. Okay? Now again, do you have to draw these? Not necessarily, okay? But do you guys remember how the tetrahedral arrangement kind of is on a CH4? Okay? You do need to know how to draw them somehow to show that you understand what a particulate drawing looks like, okay? But I don't care that you know that this one's coming out of the screen, this one's going back into the screen necessarily. It's hard to draw in 3 dimensions when you've got a 2-dimensional screen to work with, okay? But that's the difference between a symbolic representation over here and a particulate drawing over here, okay? And there are a lot of good pictures in the book that kind of represent this, so I just want you to be familiar with both ways of looking at it, okay? And we're going to do some practice on that in just a second. I know we don't have a lot of time here. We have very little time, actually. So we may have to, well, we will have to continue this tomorrow, which is fine, because tomorrow is just conversions, moles to grams, grams to moles. You guys know how to do that stuff, too. I'm not too worried about that one. Now, they do talk about biogeochemical cycles, okay? So, this is on the AP exam, all right? Which means they may ask a question about a biogeochemical cycle, assuming that you understand it. The most important ones, I would argue, are the carbon cycle, the nitrogen cycle, and the water cycle. And I know we've talked about these in biology before, haven't we? You guys remember talking about those cycles? Okay? So the carbon cycle, basically, trees breathe in the carbon dioxide. We breathe it out, right? Okay, I mean, that's essentially, there's a lot more to it than that, because there's also carbon that gets released from dead, decaying matter, and that sort of thing, goes up into the atmosphere, gets retaken up by the trees, okay? And so there's a cycle. The nitrogen cycle, again, has to do with living organisms taking up the nitrogen from the soil. When they die, they give it back to the soil. That's a really important process. And the water cycle, okay, obviously precipitation, right? So it rains, re-evaporates, re-rains, moves around. So you need to know how each of those cycles works and how they show the conservation of atoms, okay? Because that's on the new AP exam. Coefficient and subscript, we know the difference between those, right? I hope. Okay. Which one can you never ever change when balancing a chemical equation? Subscript. Only change the coefficients. Balanced chemical equation, is that going to be considered a symbolic representation or a particulate drawing? That's symbolic, okay? So I think you guys have that. Tomorrow what we're going to do, oh, and then it goes into, I forgot, we talked about synthesis reactions, combination, decomposition reactions. But I would just make sure you read over any of the stuff in the new course guide. Make sure you know how to do that. Tomorrow we are going to look at we're going to practice writing balanced equations and doing particulate drawings a little bit, okay? These do not have to be perfect, but we'll take a look at that, okay? And then we'll also talk about mole conversion and stuff like that. Should be fairly simple tomorrow. If you have your safety contract, I will take those. You need them by the end of the week. By Thursday, we're going to start doing a lab. So you need